Wonderful. Okay, so yeah, Inessa gave a brief introduction of the people participating in the panel, but I just wanted to ask them to introduce themselves quickly and say a few words about how you got involved with open source or NumPy, your choice. So maybe we can start with Sebastian.
Sure. Hi, everyone. I'm Sebastian. I'm currently working at the UC Berkeley, at the Berkeley Institute for Data Science, on NumPy specifically. And I started about a decade ago, I guess. When I was in my undergrad, I started to use NumPy for my undergrad work when it was still not as big as it is today. Started answering questions on the mailing list, and at some point slid into fixing bugs and becoming a maintainer slowly over time. So my path to NumPy was to first being a user, then being someone who answers questions, and then starting to fix bugs and eventually add new features and do more things.
Cool. Matti?
Hi, I'm Matti Picus. I also started my NumPy journey at BIDS with Sebastian and Tyler, who will tell about his journey as well. I started my open source journey quite a while ago as a kind of side hobby to, as an open source consumer. I was helping businesses use open source in their software stack with licensing issues and integration issues, and eventually got sucked into not only teaching Python to MATLAB users, but to help fixing bugs via the PyPy project, PyPy, which is a Python implementation with a JIT. And that led me to NumPy. And then when BIDS offered a position, I took a full-time position as a NumPy maintainer about 4 years ago. And it's been happy ever since. Right now I'm working at Quansight Labs.
Cool, thank you. Tyler?
Hey, I'm Tyler. I work at Los Alamos in New Mexico. I also started my NumPy journey with Matti and Sebastian at BIDS in Berkeley. And I was there for a year on sabbatical. So the lab let me go on sabbatical for a little bit, which is nice. My open source journey started a really long time ago. When I was in grad school, I was using SciPy a lot and NumPy, and then I eventually started contributing to SciPy. And then when Stefan had the open source grant, that was an opportunity I couldn't turn down. Working in open source full time is quite a privilege, so it was great.
Yeah, that's very cool. I didn't even know how you folks started, so it's cool to know that. Okay, so here's the topic for today. As if you have already looked at the NumPy codebase, or if you have even tried to start understanding how that's made, you can see that it's very complicated. There's a bunch of moving pieces. There's a bunch of different sub packages to NumPy. And so one of the questions that we get asked very often is, how do you even find the functions that you're looking for? So let's say that there's a bug, someone reports a bug in the issue tracker, and you know that it is in a certain function, but how do you know where that function lives? So if you look at the NumPy code tree, there's a lot of stuff in there. There's C, there's Python. So it's a very common question for people they don't even know how to look for the function that they want to edit. So I just wanted to get a feel for how you folks deal with that. What tools do you use to find those functions in the code? Do you know the code base by heart? Do you know exactly where everything lives? And why is it that NumPy has a few functions in Python, others in C? So if you could give your perspectives on that, it would be great. And I'll keep the same order. So let's start with Sebastian, if that's okay.
Okay, so by now I actually know a lot of the code base by heart. If I see a function, I usually know where to look. But initially I would always, I use git grep a lot. I would just search for the function name. And then what you need to know is that if the function, so if you go into IPython and you do question mark, for example, on the function, you will immediately see if it's a Python function, you get the code and you know where the code is. If it's a VC function, it will also tell you that it is in multi-array umath nowadays. where it's programmed, and then you know, oh, it's in C. And then you have to go through a few steps to find the actual implementation usually. That means you go to the C file, which is the multi-array.c, which defines all the functions in the last struct. There you can just search for the name, for the Python name. And then you need to go look at that one and go on through some steps to find the actual core functionality. Because usually for any Python function, there's often, or most of the time, there's also a C function that actually implements it. There are a couple of more tricky ones, like our methods. There we have to go through multiple steps to actually find where they are. But overall, that is the way to find functionality. Then there are some things like ufuncs, the universal functions, most math functions, which also end up in a completely different module. So yeah, that's a bit more tricky to figure out, I suppose. If you grab for the functions usually, or for the names, you can usually find something, but sometimes you have to go through a few steps.
Yeah, it's interesting to know that it's not easy for other people as well. It's not, of course, with time you get experience, you kind of know what things are, but it can be a little bit daunting in the beginning, and there's no shame in finding, grabbing, using whatever tools you have available to find the functions. And if you don't, ask a maintainer and they might help you find that for you. So Matti, do you want to pick it up? Also, I wanted to know, like, can you folks clarify why some functions are so nested and that they need like one file inside the other, and then you have to edit one file to get effects on the other? Why is it so?
Yeah, I would concur with Sebastian that grep is your friend. And so you should learn any form of grep that can help you. If you're looking for a particular error message, then grepping for that actual text of that message will help a lot in the code base. If you're grepping for if you're looking for a function, then it's a little more tricky. And so what Melissa asked is, why is it so complicated? And the answer is speed. That NumPy was born 20 years ago to try and speed up Python, which is an interpreted language. So in Python, it's very easy to just do, let me see if I can actually do an example. I can do some live coding. Is that okay?
Sure, yeah.
Let's see if I can share my screen. This one. Yeah. So can you see that?
Yes, that's
so
awesome.
Is it big enough?
Yes.
Okay. So say I want to look for a Python function, and I do import NumPy as np because I'm in the directory. This is another problem with NumPy. Problem with live coding. Python import NumPy as np, and I want to find where is NumPy ones, let's say. So I know it's a function, and if it's just regular Python, I can just look for the code where the Python is, and then it'll tell me where that package is and where that code is and on what line it starts. And so I can copy paste this, and I like Vim. Sorry for everyone who doesn't, but and I can go to line 149, and I see here is the function ones. So in Python, it's very easy. But then what you see at the end of this, where the end of the long docstring goes to, is, oh, it's not actually calling ones, it's calling empty. So now I have to find empty. Okay, so we start going down the rabbit hole of finding functions. And eventually what I'll find is that there's no more Python, that it actually goes to C. And the reason it goes to a built-in function, what you would get in the command line, is because Python tries to be fast. So that's the answer to the question of why NumPy is so complicated because we try to be fast. Now, NumPy has these things that are even more complicated, which are called ufuncs, which is if you have a block of memory and you want to do the same function on every position in the memory, then we have a very fast way of going across it, but it's very complicated to find the implementation. So I think I've talked enough, but I just wanted to kind of point out like one way that you can kind of stride down into functions. If people want, I can continue going down this until we actually find where the implementation of ones is. Let me unshare.
Yeah, maybe if you find that, would you share a link in the chat and maybe people can follow that?
Sure.
On GitHub, you can share a link to the function. I think yes, it's complicated, but like we said, with experience, it becomes easier. And I think the idea is that if you have questions and you're looking at a certain issue and you're not sure if the code to fix that issue is in Python or C, ask a question in the issue and we'll be happy to answer and maybe help you find the file that you're looking to edit.
Okay. I can just.
Oh, okay, go ahead.
I can
Matti.
just continue one more step if Tyler's
sure.
okay. Is that all right? Let me just share again because I found what I wanted to find with empty. So when I looked where the empty code is, right? I went back and tried to find where empty code is. It says, nope, sorry, there's no such thing as NumPy empty. So now we know that basically NumPy empty was implemented in C. And so in order to get to that, I've got to do git grep. And basically what I do is grep on a file, which is because NumPy empty comes from NumPy, right? I know that all the attributes of NumPy dot something are going to be in a file called NumPy core. Oh, gotta go back into NumPy. Grep NumPy core source multi-array problem with live coding and fingers, multi-array module.c. Grep for empty. Okay, and here I see that empty is actually the function array empty. So this is the connection between the Python name and the C name is in this file, NumPy core source multi-array module.c. So tell me when I'm too long, Melissa, you'll cut me off, right?
Yeah, so let's stop there now,
Okay.
but maybe we can come back to it later. Just
Okay,
so
great.
we can see if there are other questions from people who are watching. If you have any questions about what Matti just did, there's one interesting question that I want to ask, and maybe you or Tyler, anyone can address that, is what if you're looking for an operator overload, such as plus, minus, or the brackets for indexing, that kind of stuff? Any answers, Tyler or Matti?
Oh, I've talked a lot, so I tend to do that, sorry.
Yeah, I'm not sure on the operator overloading. I use similar strategy to Matti and Sebastian with git grep. I would mention for finding C versus Python, I'll often do something cruder. I'll just look if it has a def before it, so you do git grep, and if there's no def before the name, it's probably not in Python. Really simple stuff like that.
Yeah, I do that def thing a lot too, so I'm glad to know other people do it. Matti, do you know about the operator overload? Like, do you have any tips, or Sebastian?
Yeah, so for operators, there is I think git grep will probably get you there most of the time. The problem is that operators have a specific API in C, Python, how they are defined, which is a method def. And that method def lives in the well-named file methods.c actually. So that's where you need to look. So so there are two different things. Methods and operators. Operators are yet more complicated in a sense, because in CPython, if you know the Python C API, they are defined through slots, and some of the slots live on the object directly. If you go to arrayObject.c, you find it, or you have to go to the specific files. So those are a little bit tricky in the sense that if you don't know how the C API works, it may be difficult to figure out where they actually live. So arrayObject is that, and then arrayObject actually pulls in from the slots from many other places. Could try to share maybe.
Yeah, go ahead.
What can I share? Oh, well, let's just share the whole screen. So at the end here.
Can you increase the font a little bit, Sebastian?
Oops, at the end of the link you send, what you get is this PyArray type. This is the definition of the array object in Python, in CPython, in C for Python. And what you see here is all of these TP as number and TP as sequence. And those things hide all the specific, or most of the operators. TP as number includes all the things like add, TP as mapping includes indexing, TP as sequence includes all the things like the in operator and all of those operators. So basically you have to follow where those are defined. And those are, I think, all defined in a file called number.c, sequence.c, mapping.c. But sometimes it's all over the place. So you will have to grab again and follow step by step through the depth of it.
Yeah, and so just a reminder so that we don't scare people away, this is like the hardest part. We're not going to go there every time. There's a lot of things to be done in Python as well. There's a lot of things to be done in other things, but this is kind of the more complicated part. So please don't run away. If that's very complicated, it is very complicated, but you don't have to touch that every time you do something on NumPy. So just a little warning. Cool. So next question is, what are your favorite debugging techniques? Do you use GDB? Do you use PyDB? What tools do you use? Do you have any techniques for debugging, finding, verifying issues, reported on GitHub, things like that? Do you have any tips, Sebastian?
Sorry, I was just trying to unshare my screen. It is not working. For debugging, I honestly often just use print, but of course then when it gets more complicated, you can use GDB and step through, which with your favorite IDE, you can probably do in the IDE itself or through the GDB terminal interface for the C code. I also personally like to use Valgrind, but it's very specific for memory errors, for certain type of errors.
Cool. Matti, do you have any tools?
I also like printing. First of all, the hardest thing in actually getting one of these bugs and working on them is to get a nice reproducer. And so if you're filing an issue, the best thing you can do for us is to give us a very clear reproducer that says, here is the version of Python I used, here is my operating system, here is my version of NumPy, and here is what I actually did from step 0, not from step 13, but from step 0 to reproduce the bug. And that helps us a lot. Otherwise, we kind of have to guess at from the error output. We can guess whether it's Windows or Linux by the way the slashes go. But you know, that makes it harder for us to kind of figure out what's actually happening. So once you have a clear reproducer and a way to run Python from 0 to actually hit the bug, then there's a number of techniques, and GDB is great, and printing is great, and usually, well, sometimes you can just stare at the code and say, oh, yeah, that's kind of what's happening in here. Let me just verify it by either printing or by hitting GDB. once you have a clear reproducer and you can see what is actually happening.
That's a good point. Yeah. Tyler, do you have any preferred methods, tools, or tricks?
I tend to use printing as well. I would mention that some NumPy bugs are so complicated that I add so many prints in Python and C that I actually lose track of the control flow. So in that case, I actually have to write down where I put the prints and which one gets printed first. And I'll often have like print A, print B, print C. I need to understand the control flow. So I actually have to label my prints because it's just getting too messy to keep track. That does happen sometimes.
Oh man, I use print here and then here 1 and then here 2 into the function, out of the function. Yeah, so I'm so glad to hear you all talk about that because I don't know how to use debuggers at all with Python and C and that complicated tooling. So yeah, I use print a lot as well. So that's good to know. Okay, so go ahead.
One more thing with GDB, when you're printing in C, you can use under file and underline to know where you are. But Python, unfortunately, doesn't have that. So you just kind of, I sometimes actually fake that when I'm doing Python printing and just say Python, you know, and like print and the file name and the line, some fake line number or a number that is close to the line number so that I'll know what's going on.
Yeah, that's interesting. And Tyler touched on something that it relates to the next question is, do you have any self-documentation techniques? Like, do you keep a scratch pad while you're debugging, or do you keep a note of the commits that you're doing, which branch you're doing the investigation on? How do you keep track of all that when you're doing multiple things at once? And even just for one bug, for verifying, knowing the steps that you took and how you did that, how do you collect all that? Because I can share my own thing is that I have this planner. Like I need pen and paper. I can't do that stuff online because I just need to write while I'm thinking. And so I keep writing the steps that I took and what I did and conclusions that I got to. And I don't know how you all feel about that. How do you do that? Maybe starting with Sebastian again.
Sorry. Yeah, I think sometimes it's necessary to try to write it down or make at least a few notes where things come from, where you go to. There are some bugs that are super complicated or so deep down, or you don't even know where they come from initially. You have to track them down first. So it can be intimidating, and then writing it down seems like a good plan, good way to deal with that.
Yeah, that's interesting. Matti, do you have any other tips?
I tend to use the GitHub issue tracker as my notes. So I usually work in blocks of about an hour. After about an hour, I should give up and try and do something else for a while. At least when I'm working on bugs. When I'm working on a new something new, then sometimes I'll work for a couple hours. But if I'm trying to do a deep debug, it's like an hour, 2 hours tops is about. Then I need to go take a walk or take a break, and then I try to summarize everything in the GitHub issue. So it's a bit annoying for some people who are getting the entire fire hose of NumPy issues and pull requests. On smaller projects, it's a little easier because there's less people who are paying attention. You have to be kind of comfortable with exposing all of your idiot mistakes on GitHub. Yeah, but usually people are kind of forgiving of that. And I try to use details. You know, you can compress GitHub information by using angle bracket details. And then it collapses it down so that people who get this in their emails, they don't get this 1,000-line email, they just get the details and they can open it up if they want. The other advantage to writing things down in GitHub issues, if you don't mind sharing your stupid mistakes, is that sometimes someone else will jump in on it and say, oh yeah, this reminds me of something I saw 5 years ago somewhere else.
Yeah, that's funny. And I'll pick it up after we finish this one, but I just want to hear Tyler's perspective on how you keep track of things.
Yeah, maybe I'll share my screen for a second if it lets me do that. Let's see. Desktop. Oh goodness, it may not let me do that. Let's see. Maybe I'll just take a screenshot and share that somehow. Can you paste images in the chat? Does it let you do that?
I don't think so, but maybe you can paste links to an MGOR or something like that.
Okay. Yeah, I use an app called Workflowy, just like a set of bullet lists. I kind of keep track of the branch name and all the comments and other stuff that's a little too verbose for GitHub issue or GitHub pull request. So I've got things like core developers add comments. I think Eric's not as active now, but he always had really detailed reviews. So I'd have all kinds of notes about what he said and then how to deal with it and that sort of thing. So
yeah, that's a good point. I do that sometimes as well when there's links involved or different kinds of issues that are related. I'll do that on Notion. I use Notion, which is very similar to Workflowy, I think, to track these issues and links and different things that I want to check, or maybe documentation, things like that. But for specific steps or things that I did, I like to keep notes on pen and paper. So that's interesting. Okay, so I just want to go back to something that Matti was saying before, is that, so I do that. I use GitHub issue tracker to post everything, and you have to get used to, or not mind that people are seeing your questions or, you know, the things that you're posting. So I just wanted to ask you all your perspectives. What happens if a contributor comes and makes a mistake when submitting their pull request? Or maybe they make a mistake when they're verifying something or when they're posting an issue. How do you see the review process for a pull request? And I think this is an interesting point, because many people may feel intimidated to post, you know, the whole working in public thing. You have to post it on GitHub. It's going to be there forever. Maybe you make a mistake and your future employers may look at that and see that you made a mistake 10 years ago when you're commenting something on NumPy. So how do you folks view that? I don't know if Sebastian is back, so maybe Matti, can you get started
I'm
on
back,
that?
yeah.
Oh, you're back, so go ahead, please.
Mistakes happen. Mistakes are normal. Mistakes are part of the process, and I think we just have to embrace them to a large chunk, and that's why review exists, right? So, in my opinion, so you don't have to be scared of including mistakes. At the end, we need a good end product without any big errors. So the more care that you try to put into doing it, the easier it becomes to review, the easier it becomes to be clear that the result is good and that we can put it into NumPy. But that doesn't have to happen up front. Some of that can happen just later on at the very end. It's just at some point it has to happen. And I don't know, I feel, so personally, I feel working in public and having this process in public actually helps understand that it was a careful process and that we went through all the steps doing it. So even if there are some errors and that need to be corrected, it's easier to know that there was a lot of care in the process done than it is if you just get a fixed full pull request where I don't know how much thought went into the things. But that's, yeah, my approach to it. I feel errors happened, it's normal and it's okay.
Matti?
I agree with everything Sebastian said. I think, so there's technically, we can push to people's pull requests, usually, unless they lock their repo. So if you're really stuck and you have no idea what you're doing and kind of like threw something out there, then usually we'll try and help you work through it, because at least you made the first step of trying, which is a big step. Like, it's not easy to make that first, you know, here's my idea. What do you think? We try not to be too cruel to people. and reviews. We try to like help people through, and in the worst case, we can actually just go in and redo their pull request. I think more problematic is pull requests that change things that we don't want to change. And then it gets a bit tricky because someone spends hours doing this thing. And in the end, like we kind of say, well, that's one way of doing it, but we're really not going to accept that in NumPy right now because lots of reasons. There was just a pull request today that we kind of rejected and closed, and we rejected, and then the poster got a little upset and closed it a little bit in anger. And that's more difficult to take. That like it hurts because someone's put a lot of effort into these things, and then like you're saying, no, sorry, we can't do that. It's not very welcoming, accepting. There's no real two ways around it. If it's not going to go in, it's not going to go in. So, what was the question? Sorry.
No, you're right. I think that's the question is what happens if a contributor makes a mistake when submitting their pull request, or how do you see the review process? And I think that's interesting to know that these things happen. And maybe if you get a pull request rejected, it's also not meaning that we don't like your work or we don't want you around, but maybe it's just not the right way to do this particular task. And so there's always room for improvement and communication and trying things out. I guess that's the end result. Tyler, do you have anything to note on this?
I'd say I'd be worried if I made a pull request that was more complicated than fixing a typo. I'd be worried if people didn't find a problem with it. I mean, NumPy is pretty complex. Matti, Sebastian, Stefan Hoyer, Ralph Gommers, Polly, like there's so many smart people. Like I'd be worried if someone didn't find at least something that could be improved if I made a non-trivial pull request, which is kind of the idea, right? So yeah, I think it's good that people find stuff.
Yeah, and back and forths and reviews are completely normal, and it's normal that you have a lot of comments and a lot of things to fix. That happens. I mean, it's not super normal, but I was saying in the chat, like 139 comments, but it could happen, right? Anyway, I guess just be aware that this is part of the process. The review is part of the process, and it just shows that we care a lot about this and we want to get the best result possible. So be open to listening to feedback as well. Cool. So next question. That's a fun one. What part of the NumPy codebase needs the most improvement in your understanding? And what is the most or the least favorite part of the codebase for you? Sebastian?
Sorry, of the codebase or of the codebase review? It's a pretty difficult question, honestly. What's the worst part or the best part of NumPy? I think the worst parts for me are always those parts where things grew over time, and that sometimes means that the same pattern is in different places in NumPy, but they don't share the same implementation necessarily. And then you have different things that slightly are inconsistent, slightly different, and you have to keep in mind that there it's slightly different than over there. And so for me, the worst part is not, I think, not actually a specific spot, but when things are similar but different in different places of the code base. There are a couple of weird things, like the NumPy scalars are particularly a strange spot where that have a lot of code and functionality in common with the normal array code, but do it themselves and really could use some cleaning up and aligning with the rest. Nice parts, I actually like a lot of the NumPy code base nowadays. Like there's a lot of pretty well structured code and pretty good code out there. I think there's just also a lot of old code that could use improvement.
Thanks for being nice about this, Sebastian. Matti?
So I think that the parts of NumPy I don't like, or I don't like reviewing PRs to, or reviewing issues about, are polynomials and masked arrays. And both of those are kind of tacked on things that don't get a lot of, masked arrays have a lot of issues about them, but they don't get a lot of love. It'd be nice if someone would pick those up as like their hobby. Masked arrays are mostly in Python. There's very little C there, and there's a lot of inconsistencies because, as someone was saying the other day or today, I think, about Laskov, what's it called? The Laskov principle, that when you subclass a NumPy array, which is what masked arrays do, you're going to have a lot of trouble. And that's what masked arrays have. And the other thing that I'm glad is going to disappear is NumPy distutils. Within a year or so, it's going to go away, so that'll be nice. Parts I like best, was that also part of the question? So I really like ufuncs myself. I mean, they're complicated, but I think they've really proved themselves as a concept that gives a lot of flexibility and a lot of ability to do really magical kind of things. I mean, like, even after ufuncs were 15 years old, we found a way to add processor-specific code in them and make these loops really, really, really fast on different processors. So, yeah, it's nice that it all works.
Nice. Tyler?
Yeah, I'd have to concur on distutils. I think our standard policy is still that you don't actually need to add regression tests when you make changes to distutils because it's just too much of a mess. So that's already a pretty strong indication that it's broken. There's race conditions in there, so you can't necessarily do parallel builds using that build system anyway. So yeah, it's got to go. I think that's pretty clear. Yeah, I also like the ufuncs. You need to take the square root of 10,000 numbers. You try to do that in a Python for loop, and it's going to be embarrassing. And it's just super, super convenient and fast and easy to understand in NumPy. So, yeah.
Okay, so I'm going to take this opportunity and tie in one of the questions in the chat. So how do deprecations work? We're talking about distutils and being deprecated and being removed from the code base. So the question is how deprecations work. I noticed that we mentioned a NumPy version near the deprecation. So who removes them in future versions? How does that work? Who wants to answer that?
Well, so what we try to do, we have a deprecation policy in place, which is a NEP. I'm not sure which number. And it states right now that we wait for at least 2 releases or 1 year to remove a deprecation. In some cases, we wait longer. There is no specific, someone will remove it definitely after the 2 years. Right now, the case is that anybody can jump in and do it. And right now, it also is the case that sometimes deprecations don't actually get removed because we forget about them. But the policy is that it is this at least 2 years is important. And in general, after that, we can remove it or see whether we should wait a bit longer, depending on the issue.
Anyone else wants to answer that?
Just that we're very cautious with deprecations, I think. It's not something that we just, decide, oh, let's deprecate something because we don't like it, like masked arrays or even matrix, the np.matrix. It's been kind of deprecated for quite a while, and we haven't really officially deprecated it. We like it that NumPy, or I like it, that NumPy doesn't change very fast, and that the same code basically will work, except for some corner cases for many, many versions. And there's always talk about this NumPy 2 thing, and we kind of decide that we're not going to do it because it would just fracture. And I think NumPy has kind of shifted over the past 5 or 6 years its focus into, rather than being the one array processing library that's going to rule the entire world, to be more of a proof of concept for array processing, and then let other libraries use its API And there's even the effort to have it cross, like have NumPy 2 actually be the array API standard, which NumPy doesn't adhere to, but you can turn it on underneath, and then all kinds of slight behavior changes happen. I don't know if that was a coherent answer to the question, but kind of where I think that we don't want to just deprecate things because they're ugly. We want to deprecate things because they're dangerous or because they're inconsistent with the way Python itself has progressed.
I think that's great, and that's a great segue because the two final questions, one from Rohit in the chat and another one that we had planned is, as a 10-year perspective, looking at the future, NumPy has a roadmap, but personally, what do you see are parts of the code base that should ideally stand the test of time or, last a long time, not being radically changed? And which do you think should be gone? And I will tie that in with what you were saying, Matti, about the array API, and add in the question by Rohit, which is the array API stuff eventually going to get rid of ND array? So will that mean that NumPy is going to change radically in the future, do you think? Or do you think we'll keep more or less the same structure, but use the array API as a way to interoperate with other libraries and maybe other implementations? And maybe if someone could give like a 5-minute introduction to the array API concept, just so people who are not familiar with that understand what we're talking about. So complicated question, but the 3 points are roadmap. How do you see NumPy in the future? Does that have anything to do with the array API? And how do you see NumPy changing? Do you think it's going to change radically or kind of stay on course? I'll put Sebastian on the spot again.
Okay. So from a change perspective, what NumPy, how NumPy will evolve, I don't see NumPy changing radically. If I ignore the array API effort for now, my opinion is that NumPy, the core design of NumPy won't change much either. What will hopefully change, I would like if like some parts of NumPy get replaced or get modernized. What I personally also would like is, I'm working on the D types, which is finishing up. I would like there to be a bigger ecosystem around that. And what I also personally would like is to make more of the NumPy internals available for other projects. So some of the stuff I'm working on, so the ufunc API, for example, could be reused by objects that are not arrays, but sparse arrays or others in principle. So I could imagine that we get an ecosystem, a new small ecosystem around NumPy that shares more of NumPy, but not necessarily, even on a lower level, even on the level of implementation details. On the other hand, I think the big thing for the next years is going to be this array API effort, in the sense that the array API is a way to, or is the effort to standardize how we write code for arrays in Python. And if we standardize that, then suddenly it doesn't matter so much anymore whether your array is implemented by NumPy or whether it's implemented by PyTorch or any other library. We can write a function, or you can write functionality that will work with any of those. And that effort is very promising in the future, I think.
Anyone else wants to talk about it? And also I'll add that would you tie this with new feature proposals and how that gets accepted or not in NumPy? Is this something that we're waiting for, having new features? Because I think that's something that sometimes comes up, is that people want to add new features to NumPy and we frequently say no. Do you mind giving perspectives on that? Maybe Tyler, you want to go next?
Yeah, I'm not sure I'm the best to comment on that. I think the array API means that, like, if you want to make a big change, like adding a new ufunc, I believe there's now there's more people that have to buy into that decision process, if I understand correctly, because they also have to sort of support that functionality in their implementations. But probably Matti and Sebastian will be better equipped to comment on that. But yeah, I mean, NumPy is at the base of the ecosystem, so there's always going to be pressure to have a strong justification for the maintenance burden and the need for something new to be added in.
I don't know if Matti has an opinion on it. I feel that NumPy, when it comes to new features, I'm sure there are new features that we should add. Some new ufuncs probably will come up and will get added, but I don't expect NumPy to get huge amount of new features in the future. What rather happens is that it is not hard to extend NumPy outside of NumPy. Like SciPy has a lot of ufuncs that work perfectly with NumPy. So a lot of these features that people think would be nice to have in NumPy actually fit much better outside of NumPy, especially now. And I think we're moving even more in this direction. And the whole standardization effort makes this even nicer, because now if someone comes along and says, I would like NumPy to work with QPy arrays, with CUDA arrays, or with GPU arrays, what we can offer is we can make it much more easy to replace the two and to write code that works with both together. What we can't offer easily is to say, well, NumPy will just work on CUDA arrays soon in the future.
Yeah, I really believe in the ecosystem. I think that SciPy and scikit-learn and the entire sci whatever dash whatever and NetworkX, they all have great communities around them, and they have a position. And it wouldn't be appropriate that NumPy take on the abilities of all these other libraries. So I think that, like Sebastian said, there's a balance between only importing one thing and only having to install one thing, and then how big that thing gets. So, yeah. I would be very happy if, like, all the attention that NumPy got in the past 4 years would transfer to some of these other libraries. I mean, NumPy got this big grant and a lot of ability to move itself, propel itself forward. It'd be nice if matplotlib and SciPy and scikit-image and these others also had large grants that they could hire maintainers to update their code bases.
Great points, folks. So yes, we are approaching the end. So there's like 5 minutes left officially. If people want to stay a little bit longer, I would be happy to as well to answer questions. But if you do have any final questions, please post them in the chat and we'll try to address them. But now I just want to give each of the maintainers some time to do some final remarks, tips, anything that we didn't ask you, but you feel is important to share. And I'll just paste in the chat our link for numpy.org/contribute, which is where you can find out more about joining the community, making contributions, and the different ways of contacting the maintainers and all the entire NumPy community. So any final remarks, tips, anything we didn't talk about that you feel would be interesting to share? Sebastian? No?
Sorry, no, I don't have any.
Matti?
Well, I always have what to say. First of all, that it would be very nice if people would get involved in the project. Like Melissa said, there's lots of things outside of diving into C code and bugs in compilers that need a lot of work, documentation and others. And again, NumPy is part of a larger ecosystem, and it would be nice if people got involved in more of the ecosystem. I will say that I opened up with this, that open source for me really provided a jumping off place for me to change my career. And I'm very thankful for that. And I think that contributing to open source just opens your eyes and your employer's eyes to so many other possibilities that there are out there in ways to contribute to the entire software ecosystem.
Tyler, any last final remarks?
I'm not as sure that my employer is as convinced, but yeah, I think it's a great community, and I think we definitely need more diversity in our core teams. So we definitely like to have people from different countries who speak different languages and have different ideas than our core teams do to enrich the core development teams.
Wonderful. So I guess that's it. Do we have any other questions? Inessa, do you want to say something or ask something?
Well, I can see 2 questions from Hit in the chat.
Yeah, I just skipped over them because they're like deep dives, so we don't want to scare people away. If we have time in the end, I guess we can do that.
Perhaps we could keep them for the next time we meet, next NumPy Newcomers Hour. Yeah, so we're almost at the top of the hour. Melissa, Sebastian, Tyler, Matti, thank you so much for being generous with your time and sharing your knowledge with us. Everyone, thank you for joining us. I know Jackson stayed up late, it's 1 in the morning in Japan. Thank you so much for being there. I'd love to hear your feedback about today's format. And if you liked it, what other topics you would like to have covered?
So there's just a tiny question that I think is worth answering in the question in the chat, which is how do newcomers find the issues to get started? You can always check the issue tracker. However, we do have a lot of issues, so I understand that it's hard to find yourself there. So I would say maybe start with documentation issues or things that you feel can be smaller in scope, and ask a maintainer to help you. Hey, is this the right direction to go in? You know, is this the right file that I should be editing? That kind of stuff. If you go to the numpy.org/contribute page, we also have a Slack space. So if you want to directly ask questions before you start contributing, or maybe checking if the issue is appropriate for you, you can join the Slack space and talk to us there. There's usually someone around, you know, at any time, because we have people from different parts of the world and so different time zones. So if you need help, just reach out over there and we'll try our best to help you and guide you in those issues. We do not have, or we do, but we don't use the good first issue label, just because sometimes it is hard to identify issues that are, you know, appropriate for newcomers, but we're doing our best. So if you want to join the Slack space, I think that's really great for communication and asking questions and